Hi, here's the lesson from 12-4. The topic is angle measures and segment lengths. And so just as an introduction problem here, you can see a circle drawn. And we're going to try to find certain angle measurements in addition to the measures of several minor arcs. We're going to find the measure of angle 1, and we want to compare it with the sum of the measures of arc AD and arc BC. Because of what I've previously learned, I know that the arc AD is twice the inscribed angle there. So the measure of arc AD is going to be equal to 140 degrees. And I'll do the same thing, and I'll focus on arc BC. And to find the measure of arc BC, I will focus on angle A here. And angle A is 30 degrees, so that means the measure of arc BC will be twice that, which is 60 degrees. So I know automatically there the sum is going to be 200 degrees. Now let me go back to my triangle sum theorem. And when I look at the triangle here from A to B to this point right here, there's my triangle. 30 plus 70 is 100. When I take 100 away from 180, I find that this angle right here, it's not really labeled, but we'll say that that angle then is 80 degrees, which is supplementary to angle 1. So then I'll say the measure of angle 1 is equal to 100 degrees. When I compare these two now, it appears to me as if I take half the sum of these two arcs over here, AD and BC, it will equal the measure of angle 1. Now before we get to our first theorem, we just need to know some vocabulary words here. Our two words we're going to need to know is the difference between a tangent line and a secant line. And I've color-coded them here to where the tangent lines are blue, the secant lines are red. Our definition for secant is that as the line extends forever, when it hits a circle, it always hits that circle in two spots. You can see there it is intersecting our circle in two spots. And when you compare that to a tangent line, that tangent line sort of just glances right there on the side, and it only hits that edge of the circle at one point. One other piece about tangent lines is if we drew in a radius from the center of the circle to the edge where that tangent line hits, those two lines will be perpendicular to each other. So that's a special property of tangent lines. Now going back to that introduction, here's our first two theorems, theorem 12-13 and 12-14. So this first one, it is talking about what we just found out to be the case in the introduction. The measure of that angle is going to be 1/2 the sum of the arc on one side and the arc on the other. So in this case, if we add together x plus y, we multiply it by 1/2, we will get the measurement of angle 1. Let me add to my drawing here. If I write in a number 2, couldn't I also say that the measure of angle 2 is equal to 1/2 x plus y? And that of course is true because 1 and 2 are vertical angles and they'll also be congruent. So it doesn't matter whether I'm trying to find the measurement of angle 1 or the measurement of angle 2 there, because they are congruent angles. Theorem 12-14, the measure of an angle formed by two lines that intersect outside a circle is half the difference of the measures of the intercepted arcs. And so we have these three different cases here, but regardless of which case we have, we're always going to use this same formula, where the measurement of angle 1 is going to be 1/2 the difference of the intercepted arcs. So notice that we'll always have the larger arc, and we will take the smaller arc away from that. And so in case 1, you can see we have two secant lines. In case 2, we have one secant and one tangent line. And you can see there how it's a tangent because it just hits there at that one point, whereas this is a secant and it hits at two different places. And then in case 3, we have two tangent lines. And so regardless of what our diagram looks like, we'll use this same formula. Find the difference of our two arcs and then multiply that by 1/2. So now let's use those two theorems to solve for x here. Because this point is within the circle, I'm going to use the first theorem, and I'm going to say x is equal to 1/2 the sum of the two arcs. So this will be 90 plus 46. And now this is just a simple evaluate problem to where I take 1/2, that's going to be 136, and 1/2 of 136 is 68. Now I focus here on B, and because this point is outside of my circle, I'm going to find the difference of these two arcs. There's my larger arc, so I will take that, 95, and I will subtract z from it. So I'll say 20 equals 1/2 95 minus z. There's my equation. I need to solve that. I'm going to cancel out the 1/2 by multiplying by the reciprocal. So I get 40 equals 95 minus z. I'm going to take my z to the left side, so I'll add z to both sides. And at the same time, I will subtract 40. So I'll get a positive z equals 55 degrees.